Good day, class. My name is Abraham. I'm here to teach you physics. And if you have any question, you are free to ask in the comment section. But don't forget to subscribe for more lessons. So today, the topic before us is physical quantity. When you say physical quantity in physics, these are measurable quantity. That is quantity that we can know their size, the magnitude. For instance, a typical example of physical quantity is mass. When you say mass of any substance can be 2 kg, 4 kg, 5 kg. That 2 kg is the size of magnitude. It means you know the size. Another example is time. Time is measured in seconds. When you measure time, it can be 2 o'clock, 3 o'clock, or any depending on the specific time you want to measure. Another example is length. Length is measured in meter. So when you say length of anything, it can be rectangle, it can be one-dimensional, it can be two-dimensional. For instance, we want to take one-dimensional, that would be 2 meters. Two-dimensional, maybe 2 meters. Now, we have two types of physical quantity, which are one, fundamental quantity, or you call it basic quantity. Two, derived quantities. Let's take them one after the other. The first one, fundamental quantity. Fundamental quantity or basic quantity are those quantities from which all other quantities have been derived in physics. For instance, as I mentioned, go. Let's take it one after the other. The first one, fundamental quantity, as I said, or basic quantity. Fundamental quantity in physics are those quantities from which all other physical quantities are being derived. As I mentioned example under the physical quantity. Example of fundamental quantity are mass, length, time, current, luminous intensity. Examples of fundamental quantity. One, mass. Two, length. Three, time. Four, current. Five, temperature. Six, luminous intensity. And number seven, amount of substance. So these are the basic. Now, the next thing, according to physics, we always deal with unit. We also have what we call fundamental unit. When you say fundamental unit, it's very simple. The fundamental unit means the unit of fundamental quantity. For instance, we made mention of mass. Mass. The unit of mass is kilogram. And the symbol is kg. Number two that we mentioned is length. The unit of length is meter, and the symbol is m. We also mention number three, time. The unit of time is second. The symbol is s. We also mention current. The unit of current is ampere, and the symbol is A. We also mention temperature. The unit of temperature is Kelvin, and the symbol is K. We also mention luminous intensity. Luminous intensity. The symbol, the unit for this one is candela. Candela. And the symbol is CD. And the last that we mentioned is amount of substance. Amount of substance. And the symbol is mole. The unit is mole and the symbol is mole. Now, from the list of the fundamental quantity we have about, there are three major ones which are very, very important in physics. We cannot do without them. Which are, let me write it, the three major fundamental quantity, which are 1, mass, 2, length, and 3, time. These three are very, very important. When we get to the dimension of physical quantity, you know the importance of these three. It is from these three that we can derive the formula and the unit of other physical quantity. Now, the next thing is SI unit. This is also very, very important in physics. You can ask from the list of fundamental quantity we've mentioned so far. A particular unit is written in front of each. Such unit is called SI unit. SI unit. SI unit. This means International System of Unit. International System of Unit. That is, for each quantity, for the unit to be uniformly agreed, a particular. Now, for each quantity, as we have mentioned, there is a specific international system of units. That is, this unit that is generally accepted throughout the world. For instance, as we mentioned, mass. The SI unit of mass, as I said, is kilogram. Length. The SI unit of length is meter. Time. The SI unit of length is second. Little to temperature. The SI unit is Kelvin. Current. The SI unit is ampere. Don't forget we mentioned all this one before, just to remind you and to link it then with this, what you call international system of units. So as I told you the other time, that the three major fundamental quantities are mass, length, and time. So these three quantities now form the basic major quantity. Basic major quantities. Which are mass, length, and time. Now, their unit is kilogram, meter, seconds. Therefore, in physics, the three major basic units that we have are kilogram, meter, second. The kilogram is for mass, meter is for length, while second is for time. You need to take note of this one very well because it is very, very important in the nearest topic. So, as I said, to repeat myself, the three major basic quantities we have are mass, length, and time, and their unit. kilogram meter second. The next thing is derived quantities. Derived quantity. For as the name sound, derived quantity. That is, what this one means that derived quantity are those quantities in physics that can be formed by the combination of two or more fundamental quantity. I take it again. Derived quantity in physics are those quantities that can be formed from combination of two or more fundamental quantity. It means from that statement, derived quantity depend on fundamental quantities. They can't stand alone. You can only have derived quantity when you combine two or more fundamental quantities together. A typical example is area. Area in mathematics, depending on the shape we want to use. Let's pick example, area of a rectangle. In mathematics, we said the area is length times breadth. Now you can now see that length, we've already mentioned it under fundamental quantity, but we've never mentioned breadth. That's so that in under fundamental quantity, we have some hidden fundamental quantity which we cannot mention, but they too are fundamental quantity. A typical example is breadth, but this breadth is under length. That is why the unit of length is meter. At the same time, the unit of breadth is meter. The unit of breadth is taken from length. That is why you have the unit of area as meter scale. Another example is volume. Volume also depends on the shape we want to take in mathematics. Let's take the shape of the cubed. You know, volume of a cubed in mathematics is length times breadth times height. Note this one again. Here we have length times breadth. Here we have length times breadth times height. You should notice something that this height also is fundamental quantity, but it is another hidden fundamental quantity, which is under length. Length times breadth times height. You can now say that height is another fundamental quantity. Because I told you under breadth, height also is an hidden fundamental quantity, which is under length. Therefore, the unit of length, as we said, is meter. Unit, meter, multiplied by meter, multiplied by meter. This one, meter cube. Can now say that the unit of volume in mathematics is meter cube. And mind you, we are talking about SI unit, that is this international system of unit. Note, because in mathematics, you can have the unit of length as centimeter. Yes, it's true. But don't forget, this is physics. We are talking about SI unit. So the SI unit of area is meter square. That of volume is meter cube. Another example is density. 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 Now, the formula for density is mass over volume. Mass over volume. Don't forget what I said, that derived quantity are formed by the combination of two or more fundamental quantity. Now you can now say that density is mass over volume. Question can be asked, either in objective or theory, that how many quantity that constitute by density. So you can quickly, from what we have written on the board, you can quickly notice them by yourself. One, mass. Don't forget, volume also is a derived. But what are the quantities that constitute volume? 1, 2, 3. It means for density now to be a derived quantity, there are 4 different fundamental quantities that follow, which are mass, length, breadth, and height. That is why we have density above mass over volume. That's why the unit of volume and the unit of density will now be, for mass, the unit is kilogram. For volume, as we said, the unit is meter. Then you can now say the unit of density is kilogram per meter cube. Or you can write it rather like this, kilogram per meter cube. Now, from what I've written, you will notice that I say kilogram per meter cube. This minus indicator is the same thing as this per. Let me give you an example, brief rule from mathematics indices. When you say 1 over a in mass, this one will give us a raised to power minus 1. Do you agree? You say 1 over a squared, it will give us a raised to power minus 2. The total, when you have 1 over a raised to power, it give us a raised to power minus 3. If you compare with this one, m raised to power minus 3 will give us what? 1 over m raised to power 3. And if you want to express this one further, it's better when you say kilogram over kilogram per meter cube. This is what it means, kilogram multiplied by 1 over meter cube. Apply that law of indices, you now say that it's still the same thing. It's either you say kilogram per meter cube, you say minus, or you use that slash per. God bless you. Let's move further to other example under derived quantity. We've mentioned 1, 2, 3, 3. Let's mention more. The next one is force. Force is another derived quantity. And what is the formula or derivation of force? That's mass multiplied by linear acceleration. Mass multiplied by linear acceleration. Don't forget it is because of time. Acceleration itself also is a force, as I said, is mass multiplied by linear acceleration. To sort it, that one will now be m multiplied by a. Now, from what I've written on the board, I said derived quantity formed by the combination of 2 or more fundamental quantity. You ask that question, is acceleration a fundamental? The answer is no. Now, you can now express further. Mass multiplied by acceleration, as you know, is velocity over time taken. Now, you can now see from what I've written on the board now, this word acceleration, we say is velocity over time taken. Another problem has arisen from what you have written, because we say combination of 2 or more. Velocity is not a fundamental. We need to get the fundamental of velocity also. Then we are going to have mass multiplied by velocity is what? Displacement over time taken. Displacement over time taken. Don't forget, there's another time taken here, then over t time taken again. Now, from what we've written here, you can now, let's use symbol so that it can be easier for us. Mass for m, displacement for d, over time taken, t for time taken. This is another t. Then we are going to write in symbol as force F will be equal to md over time. Use your mathematics method divided by 1 over t. Now, from what I've written, M stood for mass, D for displacement, as I've written there, T for time taking. But mark you, the reason for splitting this one like this is that we have over T, that is divided by T. And that one will be 1 over T. Sorry. Now, from what we have seen now, from here, nd over t divided by t, that is nd over t divided by t. Now, what I'm trying to say the other time is that use fraction method. Now say divided by 1. This one will now give us md over t multiplied by 1 over t. From there, you are going to have md over t squared. Now, from what we have done now, don't forget M is for mass, D is for displacement, and T is for. What I've written so far to explain further, MD multiplied by 1, it will give us MD. T multiplied by T, it will give us T squared. Now to continue, a question can be asked now. As I had the other time, how many quantities that make up density? And from there, we could say that it is 4 quantities, 4 fundamental quantities. Now, the same question can be asked, maybe in objective or in theory, that how many quantity form force? Now, from this point now, the same question I asked the other time under density can be asked. That how many quantity form force? Let's count it together. Mass is fundamental, that's 1. Displacement is fundamental, that is 2. This is t squared, making 2. It means we have 4 quantities. Take note of that because of objective question. That how many quantity form force? You may have 1, 2, 3, 4. And the best option for that one will be 4. Because from what we can see on the board, this is 4 quantity. Note, if you want to count from here, you can now see that this is mass multiplied by evaluated time divided by time taken. They also are quantity. But mark we are talking about fundamental quantity. Velocity is not fundamental. That is why we cannot count velocity as a whole quantity. It has many quantities inside. But since we have splitted the whole thing like this, we're able to know how many quantity exactly that we can see from force, which is 4 quantity. Let me give you more example. That one is number 4. Take number 5. Now, please don't forget to subscribe and ask your question in the comment section. Number 5. Number 5, let's take surface tension. This is another derived quantity. As I said, there are many. We are going to mention but few. The formula for surface tension is force over length. You can now say that we already know something about force. Length is already known. Now, from here now, the unit of surface tension can be Newton per meter. That the word Newton come from force. Meter from length, that is unit. The first unit can be Newton per meter. That's it. We can call this one derived unit. Now, as I said, force over length. Let me take you back to this force now. Force, according to what we have written so far, force, according to the formula, we say is mass multiplied by linear acceleration, which we mentioned the other time. I don't want to write the possible unit for force for you before we move to surface tension again. The unit now, possible unit for force. 1. The common one you know from GSS classes is Newton. The common unit you know for force from basic classes is Newton. That is common. But when you now get to physics now, it is now possible for you to know more about force. So we can now say another unit for force can be mass is kilogram. Acceleration is meter per second square. Meter per second square. So the unit of force also can be kilogram meter per second square. So this is the two possible units of force. Let's now go back to surface tension now. Surface tension. From this surface tension, I've already said the first unit that we can have is Newton per meter. That's the first unit. Again, if we still express further, we can still get another unit. Don't forget we've said force is ma, then over length. If it is ma over length, a is acceleration. We can still express further. We want to get another unit, mv over lt. Don't forget acceleration is velocity over time taken. Mind you, velocity is still derived. You can still reduce it to a fundamental level. Let's continue from this side. Now, our surface tension can now be md over l dLtt. Now, from here now, you can still see md over t square. So we can now have over l t square. We can now have another unit. This one, mass, another unit of surface tension now can be mass, the unit is kilogram, displacement is meter, over length is meter, time is second. Then this one, we cancel this one. So you can now have the unit of surface tension as kilogram per second square. Or, as I said the other time, kilogram per second square. Therefore, it means surface tension, we have two units. Number 1, Newton per meter. In short form, Newton per meter. The second one, kilogram per second square. Take note. Now note this one. In an objective question, the question can be asked, which pair of the following unit is for surface tension? You will now write Newton per meter and kilogram per meter square and give you another wrong 3 options. Note, you should be able to note that the correct unit for surface tension are Newton per meter and kilogram per second square. I think it's clear. That is number 5. Let's move to another example. Because as I told you, we have many derived quantities. And the next one we are going to is work. Work. The formula for work is force multiplied by distance. Force multiplied by distance, that is F multiplied by D. F multiplied by D. Don't forget, displacement is being represented by D. As we said the other time, distance also is represented by D. When we get to the next topic, we know the difference between the two. But for now, We take them as fundamental quantity. And as I said the other time, they are hidden quantity. Hidden quantity under length. That's why you can say that displacement, the unit is meter. Distance also we take meter. Now, from here now, the first unit of work, as you know from basic classes, is, let me write the unit here. Number one, Joule. That's the first unit of work that we already know from basic class. Another one from this formula that we written now is, you know that the other time I said first is Newton, which is written here. This time will be meter. So another unit can be Newton meter. That's number 2 unit. Again, if we still express further, because we must relate derived to fundamental quantity. And what we are looking at, how many fundamental quantity does work can take? We've not get to the final destination. We need to express further. So let's express further. Mass force is what? MA. MA. That is MAD. MAD. Here we can have another unit because mass is what? Kilogram. A is what? Meter per second square. So if you write it together, then it will now be number 3 unit. Kilogram meter per second square multiplied by meter. And from there, we are going to have kilogram meter square per second square. That is another unit of work. Now, from here, you can now see that where are we going? Don't forget our fundamental, that we must get the fundamental of each derived quantity from the definition. That derived quantity are those quantities that are being formed from combination of two or more. But from where we are now, we cannot say that acceleration is not a fundamental. So we cannot say 1, 2, 3 for work now. We need to move further. Let's move further by expressing it further. Then from here, MAD. MAD. A is derived. We can now say mvd over t. Where do we got this v over t? Acceleration is velocity over time taken. Now we've gotten 4 quantities, but there is still one there that is not fundamental. So if you count 1, 2, 3, 4 now, and the question asks you how many quantities form work, and you say 4, oh, it's totally wrong. Let's proceed and see. Velocity is what? Displacement over time taken. That will be mdd over tt. From here now, displacement and distance. Don't forget I told you there are some hidden fundamental quantities. This one is work, not force. Work is equal to, from where we stop here, work is equal to MAD. So that we, as I've said to this point, mdd over t square. So it will now give us md square over t square. md square over t square. Now if we are now asked how many quantity, because now from this point now, you can now say that m is for displacement, m is for mass, d is for displacement combined with distance, and t is time taken. Let's now count the number of quantity now. M1, distance, displacement, making 3, time, making how many? That is 2, 3, making 5. So if the question asks you how many quantity does work contain, the answer is 5 from what we have done. So you can now see that from the last unit we wrote now, let's look at it together. Mass is for kilogram. This one, if we take the same unit, that's m squared, then over second square. Do it as I explained in the beginning. That will be kilogram meter square per second square. If you compare what we have written down, you cannot say that it's the same. Therefore, you cannot say that work now, instead of joule that we've known as the unit of joule before, we have other two units, which are Newton meter and kilogram meter square per second square. Now, in an objective question can be given that all the following are unit of work except, you know already we have three. That is why you must know all the three offhand. All the units below are for work except, you now say A, maybe the A option will be the wrong one. They may put kilogram per meter square per second square. B, Newton meter. C, kilogram meter square per second square. And D, joule. You cannot say that from that my question that if you are not careful, look at the option A, it seems as if it's the correct, but it's not the correct one. It's the wrong option there. You can now say that from the list of this option now, only A is wrong. Why? M raised to power minus 2. But the correct should be what? M raised to power 2 only. Therefore, the correct answer, that if the question say all the following are unit of work except, the correct option is A. Don't forget to subscribe, and in the comment section, ask your question and to be answered. Mind you, if your question is not based on this topic, you are free to ask your question in any topic. Once it is physics question, your question will be answered. Thank you.